Okay, so let's begin. I hope that you have the question with you. You want to say long, it's not very long actually. Today there are a lot of questions, but it shouldn't be too long. So let's begin with the first question together. So look at this question. It's telling you like this. Fuji Software has the following mutually exclusive project. Suppose Fuji payback period cut off is 2 years. Which of these two projects should be chosen? So they're telling you that the payback period is cut off at 2 years. So anything more than 2 years, you won't accept. So B, suppose Fuji uses the NPV rule to rank this project. Which project should be chosen if the appropriate discount rate is 15%? So you need to do two things here. A is to count payback periods. B is to talk about the NPV. So as you see, the question give you, this is the cash flow. So I think you guys can see it on your question, but I'll write it out so you can see it easily. Project A, Project B, negative 15,000, 9,500, 6,000, and 2,400. Project B, negative 18,000, 10,500, 7K, 6K. These are the information given to you. So the first one, they want you to calculate the years. How many years for the payback period? So you see matching or not? So very simple to do the payback period. You see, 15,000 minus 9,005. So how much is it here? 15. Let's do PA first. 15,000 minus 9,005. This is left with 5,005. So negative 5,005 here. Negative 5,005 plus 6,000 become positive 500. Okay, become positive 500. So that means the break even will take place at here. So it's 1 year. Okay, first year cash flow is 9,005. So 15,000 minus 9,005, you left with 5,005. The balance will be on year in between year 1 to year 2. So you can count that now. So definitely going to be 1 year. So the payback period for A definitely take 1 year. So full year cash flow here you taken. So 1 year plus you still got balance. Okay, balance of how much? You need a balance of 5,500. 5,500 out of 6,000. Okay, so this will tell you how many years left. 55 divided by 60 is how much? Let's count. 55 divided by 60. 0.916. So this is actually 1 plus 0.916. So it's 1.916 years or 1.92 years. So 1.92 years, okay, for project A. Whereas for project B, 18,000 plus 10,500, the balance is 7,500. 7,500 plus 7,000. So here haven't clear yet. So it's not clear here. So 7,000 some more. So here we left with balance 500, negative 500. So that means it go to between year 2 to year 3. So the payback period for B all right, 1 year, 2 year. So 2 year. Okay, so 2 year and balance 500 over the third year 6,000. 500 over 6,000. Okay, so 1 out of 12. So 2 plus 1 out of 12. You get 2.083 years. So the criteria of the question is they tell you, suppose Fuji's payback period cutoff is 2 years. Which of these two projects should be chosen? So anything less than 2 years will be chosen. So project A is 1.92. So it's definitely less than 2 years. So you accept. Project B is 2.083. So it's more than 2 years. So you reject this project. You only accept the one before the cutoff period. Okay? So it's shorter than the cutoff period. So you only choose project A. Clear or not? So far. Anyone confused on payback period? Anybody having any issues? Just let me know if you're facing any difficulty. Okay, only Sauchen responded. So the rest, if you did not write anything on the chat, I assume you got no issues. But if you have issues, please let me know. So that's for payback period. So part B of the question, all right, they want you to find the NPV. Okay, very good. All no issues. Part B, they want you to find the NPV with a discounted rate of 15%. So NPV, you know, okay, I think you did NPV in other units before coming to corporate finance. At least all of you did intro to finance. So definitely you do NPV before. So how to do NPV? NPV formula is very simple. Okay, for NPVA, the negative initial investment is negative 15,000. All right, then plus all the cash flow, 9,500 and discounted by the discounted rate. So 1 plus 0.15, 15%, right? 1 plus 0.15 power of 1 plus the next cash flow, 6,000, 1.15 power of 2 and 2,400, 1.15 power of 3. So this is the formula to count your net present value. Okay, it's very easy, very straightforward. All right. So those who use calculator, I think you already know how to use it. I will show you one time. So in case you might forgotten already from your previous semester or whatsoever. Okay. So if you use your scientific calculator, you key in one by one, calculate your NPV. For those who use financial calculator, you fill in your CF at 0.0, your cash flow at time 0, negative 18,000. Cash flow at time 1, 10,500. Your F01, keep it as 1. That means this is only repeated once. F means frequency, once. Cash flow 2. Sorry, this one is wrong. Only this is for B. Is for A means it's negative 15,000. Negative 15,000, 9,500. Frequency once. Cash flow 2, 6,000. Frequency of cash flow 2 once. CO3, cash flow number 3, 2,400. And then frequency of cash flow 3, only one time. Key in your IY as 15. Then lastly, compute NPV. These two will have the same answer. Okay? Both of it, you should be getting 625.23. Negative. Negative, Negative 624.23. Then do this for project B. So project A, you get 624.23. So it's a negative one. So project B, repeat what I tell you just now. NPV B is equal. It started off with negative 18,000 plus cash flow 10,500 discounted by 1 plus 1, 0.15 power of 1 plus 7K 1.15 power of 2, and lastly, plus 6K, 1.15 power of 3. So if you use scientific calculator, key one by one, and you can get the answer. So repeat this with this same method for your financial calculator, and you compute your NPV. So project B, you get 368.54 positive. Okay, so based on the NPV, which one should you accept and which one should you reject? So if you base on NPV with a 15% discount rate, all right, you should choose project B since it has a positive NPV. and also a higher NPV. If it's a negative one, that means this project is making losses, so you reject. So as you can see, if you use the payback period, all right, just now you look at payback period, it calculated reject B, accept A. But when you use NPV, you accept B, reject A. So which one will be more accurate? All right. So remember this. If you have taken your intro to finance, you should know that NPV, okay, and IRR will be a decision maker. Okay, will be a decision maker. Payback period is just giving you a rough one. Okay, a rough estimation. All right. So NPV will be a much more accurate decision maker. Keep that in mind. So when you compute NPV, it tell you which one will be more profitable. After discounting it, then take that. That will be a more valid one. Okay. So I think this is quite simple so far. NPV is something you did before, and payback period is very straightforward. All right. So do you have any more questions or any questions before I move on? No? Okay. Very good. So now we move to question number 2. Very good. So if anything that you need an assistant, please stop me. Don't wait. So question number 2 is a bit different here. All right. It's a very simple one. So they tell you an investment project provides a cash inflow of $840 per year for 8 years. What is the project payback period if the initial cost is $3,200? What if the initial cost is $4,800? And what if it is $7,300? Okay. So very simple, because the cash flow is same throughout the year. It's equal. All right. So when you count the payback, it's very simple. Okay. So if let's say the initial cost is 3,200. All right. So 3,200 divided by 8 years, you take how long? Okay. It doesn't care about the cash inflow, So you just want to take the initial cost of 3,200. All right. And divided by 8 for the first one. Okay. What if the project period of the initial cost is 3,200? Okay. So if it's 3,000, if 3,200, very easy. Your payback period is 3,200 divided by 840 per year. So let's see how many years you get back your payback period. Okay. So if it's 4,800, again, the payback period is 4,800 divided by 840 per year. Each year you get how many years you get back. And lastly, you repeat it for if it's 7,300. $7,300 divided by 840. Okay, so let's count one by one. 3,200 divided by 840. How much you get? 3,200 divided by 840. You get 3.809 or 3.81 years. This one, 4,008 divided by 840. 5.71 years. And lastly, 7,300 divided by 840. 7,300 divided by 840. So you get 8.69 years. So the question tell you cash flow is only 840 for 8 years. All right. So A, this one, yes. Okay. This is very good. That means you get back your payback period in 3.81 years, very fast. All right. B is also 5.71 years. But this one, 8.69 years, already exceeded 8 years. This one means no payback. All right. How can you be 0.69 years? Because it's only giving you 8 years of cash flow 840. So for this, you take 8.69 years to get back everything. So this one, you won't get any recovery. So no payback. Okay, means this is got no payback. You don't get any payback at all. Because you calculated it take 8.69 years to get back your money. So if you invested with 7,300 capital, in this case means you don't earn back anything. All right. For the first case, you will get back your investment at 3.81 years. And then the balance is your profit lah. Because 8 years, right? Balance is your profit. As for this one, 4,008, you get back your profit at 5.71 years. And the balance is going to be your profit. This one, you don't get any profit. You're making losses because you don't have the 9 years to pay you back 840 to recover the 0.69. So you will be at loss. Can get it or not? Very easy. This one is very simple. Take the initial capital divided by the cash flow per year and see how many years you get back your initial investment. Then compare with the period of time that you receive the payment. So if it's less than the period time that the payment is given to you in an annual basis, then yes, you can invest on that. But if you take more than the years of payment, then you don't get any return of capital. So that will be a losses, especially this last investment here. You don't get back your money. So this is not a good investment. You will reject this project. Okay? You'll reject this project. Can, huh? So far, okay. Any questions? No. Very good. Very, very good. Okay, no questions. We move on. Question number 3. What is the net present value of a project with the following cash flow and the required rate of 12%? Okay, if you have the questions, you can see. This one want you to count NPV. So NPV, no rocket science. Very simple. Initial investment, negative 28,900. First year, 12,450 divided by 1 plus R. R here is 12%, 0.12 power of 1. Plus 19,630, 1 plus 0.12 power of 2. And lastly, 2,750, 1.12 power of 3. Sum it up with your scientific calculator. If you're using financial calculator, do as what I showed to you previously. Okay, NPV compute. So this question, you'll be getting, add on together one by one. Hopefully you're trying it. Okay, I'll let you try. I give you spend some time, go and find out. Tell me what's the answer. Positive or negative. You can either use your scientific calculator or your financial calculator. You should be getting the same figure. Come, let me know. You all find out for me. So the faster you get me the answers, the faster we can move on, huh? Anyone got the answer already? Don't be afraid of mistakes. It's fair to have mistakes. Trisha got it, negative 177.62. All right. Sauchen also. So negative 177.62. So as long as NPV is less than 0, you reject. So in this case, It's a negative. Therefore, you reject. Very good. All right. So please try. The rest of you that have never tried answering the question, please try for the next one. Okay. It's a good practice to use, especially those who use the financial calculator one. So this is a time that you key in the input and see whether can you get it or not. Okay. Now in class, you can still try and error. But when you come into the exam, whatever given to you from a calculator, you must trust your calculator. Or you will choose to trust your calculator. So if your calculator give you a wrong figure already, you wouldn't know you're wrong or right. You'll still put it and submit. And that's where most of the students screw up, because they might use the calculator wrongly. They might not reset the calculator, or they did not do a certain things to the calculator. Okay, or the setting is not as you're supposed to use for this kind of calculation. It will spoil your end results and you will get a wrong answer. Okay, so practice. Make sure that every time you calculate, you clear the memory first. Make sure the cash flow is not recorded earlier on. Okay, so good. You get a negative NPV, means you reject. Next, question number 4. Again, they want you to calculate. They tell you what is the net present value of a project that has an initial cash flow of 12,670. So they never give you year 0. They straight give you year 1, 2, 3, 4. Year 0 is written in the sentence. Okay, so this question required return is 11.5%. So again, count NPV. So the initial cash flow they tell you is 12,670. And then the other 4 cash flow will be 4375 divided by 1 plus 0.115 is 1.115 power of 1. 0 divided by 1.115 power of 2. 8750 divided by 1.115 power of 3. And lastly, 4100 divided by 1.115 power of 4. Try out. Tell me the answer. Okay, find me the answer. Financial calculator user, make sure your cash flow at time 0 is always negative. Very fast. Okay, very fast. 218.68. Very good, Zarin. All right. So this is a positive NPV. So this is more than 0. So you accept this project. Okay, very good. Positive 218.68. So it's more than 0. So you will accept this project. All right, number 5. Number 5, Number 5, no cash flow. But they tell you like this. A project will produce cash flow of 1,750 a year for 4 years. So the project initially cost 10,600 to get started. In year 5, the project will be closed, and as a result, produce a cash inflow of 8,500. What is the net present value of this project if the required rate of return is 13.75%? So this one, I put it on a timeline, easier for you to see. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Time 0, so initial investment is the project initially cost 10,600. So negative 10,600. Then for the next 4 years, you get a cash inflow of 1,750. And on the last year, you get 8,500 extra. So the interest rate here is 13.75. Okay, so count your NPV. Negative 10,600 plus 1,750 divided by 1.1375 power of 1 plus ... Okay, repeat one by one. 1.1375 power of 4. And lastly, 8,500 divided by 1.1375 power of 5. This is for your scientific calculator. This is repeat. I did not repeat it because you repeat yourself. Power of 2, power of 3, and then power of 4. Okay. So there's an easier way for you to do if you're using a financial calculator. So of course, your CF0 at the beginning is negative 10600. All right. Then when you click down for your CO1, you put no negative. You put 1750. But the frequency of cash flow 1 is 4 times multiplication. Repeats. Then your cash flow 2 is 8,500. And your frequency of cash flow 2 is only 1. You only no repetitive, only 1 time. And lastly, you put your I, 13.75, and compute your NPV. So now, tell me what you get for this. This one, if you use financial calculator, will be faster a lot. Oh, very fast, huh? So do you use the scientific calculator or using the financial calculator? Yeah, I know. Both. Oh, Southern use both calculator. Very good. This is a good practice. Okay, so that means this formula methods, it's if you know to use your calculator, you just key in like this, you will get the answer. Because I'm afraid some of you might be using a different kind of calculator. All right, then you need to be familiarized with yourself. So you get negative 1011.4. So once you see a negative for NPV, this project is not a good project already. Okay, whenever you see a negative, this project is not a good project anymore. All right. The good thing is the question did not ask you, should you accept this project or not? But in this case, you just give the answer negative 1011.4, you already get the full mark. But if the question asks you, should you accept or reject, then you can elaborate further. Okay. All right. I hope the rest of you tried, not only Zarin and Shaochen. So please get used to your calculator. Okay. Get used to your calculator. All right. I'm not there to give you answer to double check in your exam. So you need to use your calculator. Okay. So we're done with NPV. This next question is IRR. So IRR is very hard if you don't have a financial calculator. If you don't have a financial calculator, you need to use the try and error method on your scientific calculator. So you try to input the answer one by one until you can find the end figure equals to 0. Then that is the closest percentage, or that's the most accurate one. But if you use a try and error, usually it won't be so accurate. You get a rough estimation around that particular percentage only. So let's look at question 6 together. Then we see whether you understand or not. Stone Sour has a project with the following cash flow. The company evaluates all projects who are applying the IRR rule. If the appropriate interest rate is 9%, should the company accept the project? So the benchmark here is 9%. It's not IRR equal 9%. So IRR, you need to find out. Okay. So they tell you the cash flow is negative 20,000. Let me write it out. Year 0, 1, 2, and 3. So the cash flow is negative 20,000, 8,005, 10,002, 6,002. Okay, so this is actually like NPV. Okay, this is actually like NPV. But to count IRR, you always assume NPV equals to 0. Okay, you assume NPV equals to 0. If NPV equals to 0, means 0 equals to negative 20,000 plus 8,500 divided by 1 plus IRR, power of 1. 10,200, 1 plus IRR, power of 2, and 6,200, 1 plus IRR, power of 3. So, if you use your scientific calculator, it's very hard to do this. It's a try and error. You need to figure out try and error until you get 0. Until this equation here gets 0. So put in 1 plus 0.09. That means 9%. Calculate all the answers. Then evaluate whether can you get 0 or not. So this is a try and error method. Okay. But if let's say you are lucky enough to have a financial calculator, or you manage to borrow one from your friends for the exam, so what you need to fill in for your financial calculator is same like the NPV one. So your cash flow at time 0 is negative 20,000. Then cash flow at time 1, C01 usually, not CF. C01, it's equal to 8,500. Frequency of the first cash flow is 1 time. Okay, it's not repetitive, so it's not 1 time. So C02, 10,200. Frequency of 02, 1 time. Cash flow 03, 6,200. Okay. Frequency 1 time. Straight away, compute IRR. No need to click NPV. Then you can get your answer. So this, they'll straight away give you 12.41%. But try and error, you might not get so accurate. You might get 12.4 or 12.5. Okay? Unless you can go until 12.41, then that means you take very long time. It's either you are very familiar with the percentage, all right, of the end results, you can get 12.41 exactly. If not, you spend a lot of time counting to get 12.41. So in the end of the day, going to the exam with a financial calculator, this will be your advantage. Okay, this will be your advantage. All right, this is only for calculation. So once you get 12.41 and they tell you that this project, given you that the appropriate interest rate is 9%. Okay, so 9%. So take 12.41 versus 9% expectation. You're getting more than the expectation. So this project, you can accept. Okay, so as long as when IRR is higher than your required rate of return, you accept. Okay, you accept. So I hope those who use a scientific calculator, you can try and error until you get 12.41. Okay, but in the exam, you got nothing to benchmark. You need to really count until you calculate your NPV or your total of everything is equals to 0. All right. So far for IRR, any questions? Anyone think this is so difficult? No, no questions, no issues. When you get 12.41, so when you fill in here, negative 20,000 plus 8,500, 1 plus 1 plus 0.1241, you cannot get 0. Are you sure? Let me try. Did on both calculator and answer are the same. So you cannot get 0 lah, in other words. Let me see. Did I give you the wrong answer or not? So what do you get if you count if you just compute IR, or did you get 12.41? Mm-hmm. How come? Huh? Hold on. Let me try with calculator first. Give me some time. Okay, give me some time. 1,500 divided by 7561.60. So rest of the student, you may try also while waiting for me to figure this out. Eight zero seven two point one seven. Six thousand two hundred divide by 4364.93. Seven five six 1.6 plus 072.17 plus 3.93. I got it what? If you follow my figure, can you get it or not? Sao Chen. Okay, you take negative 20,000 plus 7561.60 plus 8072.17 plus 43264.93. You can get zero what? You see the red color is the answer for each of these sections. All right. So add up together, negative 20,000 plus all this, you can get zero what? Try and see. Cannot. Okay, you try negative 20,000. Come. 20,000 minus 7561.6. 04 9999 83421. Okay. Very manual. I count very manually with you, so you guys can do alongside with me. 12438.4 minus 8072.17. 3, okay, 2, 6, 6, 3, 4. 4366? Yes. Yeah, 4366 minus 4364.93, you're left with negative 1.9. Yes, that's very close already because 12.41 is the general one because it's 4.0 something something or 41 something something. So once you get near to negative 1.9, it's very close to 0. So this is considered negligible. So you already got the answer, what? You won't get exactly 0.1 unless you put all the decimal point there, 0.409 something 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 accurately. Yes, then you can get your 0. Near to 0 is considered correct. Sachin, can you get that or not? Or you get this now, 1.9. You get negative 1.9. Ah, yeah. I thought you get a very big difference. Yeah. So yes, you get a very small difference, negative 1, negative 2, like that is fair. Because we're not using accurate decimal point. We're only using 2 decimal point, what? 12.41. All right. So it's fair to have some differences there. Unless you go and put to exact of 12.401 something 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 or 12.41 something 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 until 9, 10 decimal point, then you get closer to 0. You won't get exactly 0. Okay, got it? I should have asked how much you got. Okay, then I don't need to go and do so many works. All right, now mind, it's good. At least I showed to all of you, it's proven to you, it's almost near to 0. Okay, it's almost near to 0. All right, so let's move on. Let's move on. So if you have financial calculator, it's easier. It's way easier. If you try and error, first you need to find 12%. Then 12.1, 12.2, 12.3, 12.4 until you're going to find until 12.41. So that's going to take you a lot of time. So if you're not buying any calculator yet or don't have any calculator for financial calculator yet, you can plan to borrow from your friends first for a final, at least for your final. Okay? All right. Let's look at question number 7. Question number 7, they want you to compute the IRR for both cash flow. All right, so this is 2 different cash flow lah. Okay, so 0. Let's see what's the cash flow. 1, 2, 3. Project A, project B. Negative 5,300, 2,000, 2,800, and 1,600. This one negative 2,900, 1,100, 1,800, and 1,200. So I think don't use those with financial calculator. You can straight away calculate like what I showed you just now. All right, your CF0 is the 0. This is CF1, CF2, and this is your CF0, C01, C02, C03. Okay, F also is 1 only because never repeat. Frequency is only 1 time. All right, then compute IRR. So what do you get for A? What do you get for B? Come, give me the answer. All right, Gauss transform got 10.38 versus 19.16. Very good. Okay, so in this case, of course, you will choose the project with the higher IRR. Okay, the internal rate of return 19.16 is higher, so you choose project B. All right, choose the IRR which is having higher. Okay, so very easy. You choose the highest IRR only. Can So IRR, you must have calculator. No calculator, you use financial. You must have financial calculator. If you use scientific calculator, it take you a long time. So financial calculator, easy. Just key in your CF0, C01, C02, C03. So those who don't know how to find your cash flow, go and find out. Again, different calculator will have different ways of inputting cash flow. So go and find out how to input your cash flow. All right, practice at home yourself. Try the questions yourself. Okay, so I guess IRR shouldn't be an issue now. It's, if you can do the NPV, you can do IRR. Easy. Okay, with the calculator lah. All right, but if you're only using scientific calculator, NPV not an issue, but IRR might be an issue to you. So question number 8 here now. Suppose the following two independent investment opportunities are available to Greenplane. The appropriate discount rate is 10%. So they're telling you discount rate is 10%. Compute the profitability index for each of the two projects. Which project should Greenplane accept based on the profitability index rule? So profitability index rule is another way to calculate. All right. So how to count profitability index rule? Okay. So let's do together. So let's see the cash flow first. Again, let's see the cash flow. Year 0, 1, 2, 3. Project. Okay, alpha, just put A lah, huh? And project B. Negative 2300, 1200, 1100, and 900. Negative 3900, 800, 2300, and 2900. Okay. So, what is profitability index? PI. All right. So to count PI, if you use this PI, not recommended to use financial calculator lah, because financial calculator a bit complicated. You need to first compute your NPV first, then you add back initial investment, okay, then divide initial investment. All right. So if you use PI, the first method that you use is FC, financial calculator. So the step is number 1, compute NPV. Number 2, okay. Number 2, add back initial investment. Initial investment usually negative, right? So you compute NPV, you need add back it. Add back initial investment. Okay, then you potentially get negative figure. So ignore the negative figure, all right, and then divide initial investment. This is for those who use financial calculator. Okay, if you're not using financial calculator, you're using the standard scientific calculator. So what do you do? Scientific calculator. PI for A, it's equals to discount all of the cash flow. Okay, discount all the receiving cash flow. All right, discount all the receiving cash flow. So first one is 1,200. The discounted amount is 10%. So 1 plus R. 1 plus R is 1 plus 0.1 power of 1. Okay, second, 1,001 divided by 1.1 power of 2 plus the last one is 900 divided by 1.1 power of 3. The whole thing divided by the initial investment, 2,300. So basically, you discount your cash flow backwards, okay, and then divided by the initial investment. This is your PIA, your P index of A, the profitability index of A. So profitability index of B, repeat the cash flow, okay. So look back at your cash flow just now. They give you is what? The first year, they give you 800. Discount rate is still same, 1.1 power of 1 plus 2,300. 1 plus 1 power, 1.1 power of 2. And the third year is 2009, 1.1 power of 3. The whole thing divided by initial investment of 3,000 900. So count, what is your PI? All right, 1.16 and 1.23. All right, so when you're doing a comparison of PI, choose the highest. Okay, choose the highest profitability. So in this case, the highest profitability is 1.23. Okay, 1.23. So when you see this question, 1.23 here, this is your profitability index. So what does profitability index means? When your profitability index more than 1 means you profit enough to cover costs. So if this is not a comparison, when PI is less than 1, you reject. Okay, more than 1, okay, means it can cover your cost, your profit enough. Okay, if it's less than 1, you are having a higher cost than your profitability. So if it's a comparison, you choose the one with the highest PI. Just to remind you, again, PI is like payback period. All right, PI is like your payback period. It's just a rough estimation. So remember, the only one that can make decision is NPV and IRR. These two is the only one that can make decision exactly on what exactly on your project that you want to do. The rest is just estimation. Okay? Can Can understand? Can understand? Until here so far. Very good. Okay, very good. All right. So moving on, the next few questions are more likely is something that will be questioned to you in your exams or in your tests or whatsoever. All right. So look at the question, how it looks like. Consider the following cash flow on two mutually exclusive projects for the Phuket Recreation Corporation. Both projects require an annual return of 14%. As the financial analyst for Phuket Recreation Corporation, you are asked the following question. If your decision rule is to accept the project with greater IRR, which project should you choose? So A, very obvious, find IRR. So B is what? Because you are fully aware of the IRR rule scale problem, you calculate the incremental IRR for the cash flow. Based on your computation, which project should you choose? Number 2, after finding IRR, they want you to find incremental IRR. We will cover this. This is new. Incremental IRR. And lastly, C, to be prudent, you compute the NPV for both projects. Which project should you choose? It is consistent with the incremental IRR. So C, they want you to find NPV. Three things to do now. Okay, so the incremental IRR is the one that you don't know. Okay, to find IRR is easy, you already did before. So let's see the cash flow now. Look at the cash flow. Year 0, 1, 2, 3. You got deep water and new submarine. Deep water fishing and new submarine, right? Deep water negative 950,000, 370,000, 510,000, and 420,000. Negative 1.85 million, 900,000 cash flow, 800,000, and 750,000. Okay, so to count IRR, very simple. Just key in like what I tell you just now. Okay, CF, okay, CF 0, C01, C02, and C03. Frequency all the same. Okay, compute IRR. All right. So for deep water fishing, you would get 17.07%. For submarine ride, you get 16.03%. So from IRR, you see that deep water will be better. Okay, you see deep water will be better. So next, all right, next it's to count incremental IRR. How to count incremental IRR? All right, so incremental IRR, you need to subtract the smaller project cash flow from the larger project cash flow. Okay, so in this case, you take the new submarine, right, minus off your deep water cash flow. Okay, then you get an incremental cash flow. Then from the incremental cash flow, you can find the incremental IRR. So let me write it down for you. This is part A. Part B is incremental IRR. So the first step is to find the incremental cash flow. All right. How do you get the incremental cash flow? Okay. Take the bigger investment minus smaller investment. Okay. Bigger investment minus your smaller investment. So basically, your incremental cash flow is negative 1.85 million minus negative 950,000. Minus, okay, you see, negative 1.85 mil minus negative 950,000. Minus become positive. Okay, minus become positive. So 1.85 million minus okay, become 1.85 million, negative 1.85 million plus 950. So you get a negative 900,000. Okay, repeat for this. 900,000 minus 370,000, you get 530,000. 800,000 minus 510,000, you get 290,000. And then 750 minus 420, so you get 330,000. All right, so key in this incremental cash flow into your IRR formula. CF01 is negative 900,000. Cash flow at 1 is 530. Cash flow at 2, 290. Cash flow 3, 330. Okay. F is all frequency ones. Compute IRR for this. So the IRR here is the incremental IRR, 14.79. So understood or not? To count incremental IRR, you need to find your incremental cash flow. And how do you find incremental cash flow? Bigger investment minus your smaller investment. Once having the cash flow, you can find the incremental IRR. So the incremental IRR here is 14.79%. Okay. So how do you decide? How do you decide? All right. So how do you decide here? So the required rate of return is how much? Look back at the question. 14%. Okay. The required rate of return is 14%. So use this to compare versus your incremental IRR. All right. Incremental IRR. So if let's say your incremental IRR is higher than your R, in this case, yes, okay, If IRR in higher than RR, what you do is you invest on the larger project. All right, if IRR, incremental IRR, you put incremental. If incremental IRR is more than required rate of return, you invest on larger project. Okay, so in this case, 14.79 is more than 14%. So you invest on the larger project. You invest on the new submarine, right, project. Okay. All right. Can until here so far. So incremental IR basically taking the more expensive investment minus the smaller investment. If in the end of the day, the incremental IR is too higher than the discount rate, then this is value to invest. Okay, this is something that you can invest. All right. Initially, if you never use the incremental IR, you will choose this. But after taking incremental IR, you will choose this instead. Okay. So this reduce the scaling issues. All right. So after done with both of these, they want you to find the NPV. Okay. So NPV, instead of putting the IRR, we key in everything the same. So NPV, so your IRR, your interest, you put in 14%. Then you compute NPV. Okay. So you compute NPV. For those of you who use scientific calculator, then you can do one by one. NPV of deep water. Initial cash flow, negative 950K plus 370K divided by 1.14 plus 510K divided by 1.14 power of 2. And lastly, 420,000, 1.14 power of 3. So financial calculator, very easy. You already know how to do. So NPV, new submarine right. NSR is negative 1.85 million plus 900,000 plus 800,000 plus 750,000. Okay. So let's see what's the NPV. Cannot. What do you give for NPV? Come on, anyone already attempted? Come on, share with me the answer. All right. So deep water, fishing is 40,477.88. Okay, 50,477. Sorry. Another one is 61,276.34. So both also positive. Okay, both also positive. All right. So since this is bigger, you will choose, okay, the submarine right. So this is always same like the IRR. So IRR just now you see who? IR invest on who? IRR asks you to invest in a bigger investment, which is the submarine right also. So then the incremental IRR is always giving you the same answer as your NPV one. All right, which is uh, this submarine right. Okay, this submarine right. So in this case, since the NPV of the submarine right is greater than your deep water fishing, so you'll choose your submarine right project. Okay, you'll choose the submarine right project. It is more profitable. Okay, yeah, this is one of the sample that might be your exam question. I wouldn't know. All right, this might be an example of your exam question, which we don't know. Okay, most likely this is very similar to exam question, exam type question. So moving on now, moving on to question number 10. Okay, question number 10, a lot of things they ask you. Consider the following cash flow of two mutually exclusive projects for AZ motor cars. Assume the discounted rate is 10%. Okay, so first they want you to count payback, then NPV, then IRR, and lastly your increment. They ask you, is it necessary to have the incremental IRR or not? If yes, please conduct the analysis. So let's look at the difference of these two projects. Year 0, 1, 2, 3, AZM's mini and full. So mini and full. Negative 450,000, 320,000, 180,000, 150,000. Negative 800,000, 350,000, 420,000, and 290,000. So this is the cash flow. So starting off, count the payback period. Okay, payback period, PBP of mini. Negative 450 minus 320, you're left with 130. 130 out of 180. So it's over here. 1 year plus 130,000 divided by $180,000. You can get how many years for mini. Okay, for mini. So for full, 800,000 minus 350,000, you're left with 450. 450 minus 420, you're left with 30. 30 out of 290,000. PBB for full, 2 plus 30,000 divided by 290,000. So what's the answer for this proof? Anyone? Okay, you should be getting 1.72 years and 2.1 years. So based on this, you'll take the shorter payback period, of course. All right, but you must remember, payback period does not really shows that this is legit or not. So you need to look at your NPV. Okay, look at your NPV and your IRR. So NPV, again, fill into the formula. All right, CF0, okay, negative 450,000. C01, C02, C03. F is all equals to 1. All right, and then your input, your IYY. Okay, interest yield given is 10%. Compute IRR. Sorry, compute NPV. This one got IRR only. IRR is the next one. Compute NPV. Okay. So by right, you should be getting 102,366.64 for mini. As for full, you get 83,170 and 55 cents. So based on NPV, you will choose mini. Okay. Based on NPV, you will choose mini also. So just now, based on payback period, you choose mini. Now based on NPV, you also choose mini. The next one is to count the next one is IRR, to count the IRR. Okay. Part C is to count IRR. So basically, you key in everything the same like this. Then you straight away compute IRR here. Then you can get your figure. All right, you compute IRR, you get your figure. So IRR for cash flow mini, you get 24.65%. IRR for full is 15.97%. Okay, 15.97%. So based on IRR, also you will choose mini. Okay, also choose mini. So basically, out of the three evaluation, 3 out of 3 evaluation is on the investment on mini. All right, 3 out of 3 evaluation suggested that we should pick mini. Okay, so coming to the last part, okay, we ask us, is incremental IRR necessary, in this situation? Okay, so in the end of the day, it's not necessary because mini SUV has the smaller investment, okay, but then the largest NPV, so it should be accepted. How do you see that? All right, mini only started with negative 450,000 versus full, which is negative 800,000. But mini shows a much more larger NPV. Okay, so this already clearly showed that mini are more profitable compared to the full. Okay, so you don't need to use IRR because it already shows to you this is the smallest cash flow but higher NPV. So it's already the more powerful one. All right. So that's the last question. By the way, let's wrap up today's tutorial also. So before I dismiss anyone, I want to ask, do you have any questions so far? No questions. Okay, very well done. Very good. So those who have doubts,